So my name is Stephanie Momwan. I'm the Director of Communications and Sustainability at Neighborhood Sun, and this is our third Community Advocacy Board meeting of this year. Thank you all for taking the time to join us. We're going to be talking about heat pumps, and we've got two experts on board with us, Bob and Joel, who are going to be talking through all the ins and outs of heat pumps. Just a brief disclaimer that their expertise are specifically for the DMV area, but we're sharing some resources for organizations across other states, and I'll be sure to include those in the follow-up email. So hopefully we can get an organization for everyone who is interested in one in their state. I'm not sure how much. I'm sure Bob will talk about which of this information is, more generally applicable versus state by state. But just keep that in mind as we're going through the presentation today. We're going to kick things off with some Neighborhood Sun updates, and then Bob will get into his presentation about heat pumps. If you could just go to the next slide, please, Bob. Thank you so much. So our farms with current availability, if you're interested in, helping friends or neighbors get subscribed to a community solar farm, we've got availability in Maryland, in the PEPCO utility region, BGE, PEFE, and DPL. And then we've also got New Jersey availability, two projects, Island Road and Prospect Plains. So those are serving Rockland Electric, for which we currently only have availability for income qualified folks. So that's households that qualify as low or moderate income in the state of New Jersey. And then if you're not low or moderate income, there's no availability in Rockland Electric for now, but there is in PSENG. And then in Colorado, we've got availability in Excel for a community solar farm called Bickling. And then in New York, we only have availability for LMI as well, which is that low and moderate income qualified. So that's in the National Grid utility territory. And we'll be sending these slides out, so you can always look at this later and get the slides from the email. If you could go to the next slide. And just to keep in mind, when you refer folks, be sure to use your referral link. So you can get a $50 gift card, they can get a $50 gift card. And the best way to refer folks is really just to encourage them to sign up because they will be matched with the community solar farm that fits both, their utility region, their state, and their income level. So our sign up process automatically does that. So it's nice to be able to tell people, oh, there's this specific community solar farm, but the best way to do it is really just to refer them and then have them be matched up with the farm that's best for them during the sign-up process. We've got a lot of farms that are being connected to the grid and going live soon. So just a disclaimer to take these dates with a grain of salt. Unfortunately, the utility connection is out of our hands. That's up to the utility. So sometimes there are delays, and those are really out of our control. All we can do is update our subscribers on, when the delays are happening and when things are expected to move forward. So currently, for example, community solar farms Arbor View and 262 have been connected to the grid, but they have not yet started generating energy due to some utility delays. So that should be happening in the next few months. There's also a lot of farms that will be connected to the grid in November or December, and then those will start generating credits after that. So you can see the list here. I won't go through all of it, but again, you can see these slides after the meeting in case you want to check on your farm. And then we've got a few in December and January as well, and then more coming later in 2026. But I just wanted to highlight those upcoming in the next few months. Next slide, please.
Thank you, Stephanie. And thank you to all of you for being here today. Just by way of introduction, I'm Bob Sewell. I'm in Alexandria, Virginia. I'm just like you, a homeowner who happens to have gotten involved in this.
Sorry, Bob, just sorry to interrupt. Someone said that they can't see your slides, and I'm just wondering if everyone else is having that issue as well.
They have to go on the top of their Zoom screen to hit the Bob Sewell screen
Thank you,
menu.
David. Were you able to do that?
Yes, I can see the slides.
Okay, good.
Okay, we're good.
Okay, great. Yeah, so just be sure to check at the very top of the Zoom window. There's going to be a meeting tab on the left, and then there's Bob Soul's screen on the right. So just click on that screen share so you can make sure you're seeing the slides. Thanks for saying
Okay.
something.
All right. Thanks for clearing that up. Thank you. Well, as I was saying, by way of introduction, I'm here in Alexandria. I'm fundamentally a homeowner. I have electrified my own home, so I've got some experience with this, and I've gotten involved with Rewiring America and their electric coach course. And out of that, a bunch of us who went through the course formed Go Electric DMV, which is a volunteer group to help people do what we've done, which is electrify our homes. So that's who I am, and Joel is here with me. And you want to introduce yourself, Joel?
Sure. I'm Joel Rosenberg. I used to work at Rewiring America advocating for heat pumps and generally for electrifying everything in your home. I wrote a book by that title that's available on the Rewiring America website. And I'm here to support Bob and answer questions and just generally promote the idea of getting off fossil fuels in your house from a climate point of view, but also from a resilience point of view, and from just getting modern, better appliances.
Good summary, Joel. Thank you. And the division of labor here is I'll go through the slides, and Joel will correct me and answer all the hard questions. Um, but here's our agenda for today, and I'm going to do a little bit of preamble before we dive into heat pumps because there are some things that are important for getting ready for heat pumps and why they matter, and then sort of the heart of the heat pumps, and then some special topics like heat pumps in cold weather. I'm inclined to be very ambitious with my presentation, so I'll go through these very quickly. But if you have questions, we'll save time at the end to come back to things that I might have gone over more quickly than you would like. So first, starting off with the introduction, again, this is Go Electric DMV. We are an entirely volunteer group. That's our website if you want to ask for help. And we're here to help others in the area do what we've done, which is to electrify our homes and hopefully have positive experiences in doing that. Because while the electrification concept is simple and elegant, in any given home, there can be complications and challenges. And so that's what we're here to help people work through those. Our coaches typically have three things in common. We have been through the Rewiring America course, which is a 4-week course that I now help to teach after going through the first one. And we've done it ourselves in whole or in part. And we generally, like Joel, have the view that electrification is the way to not just address the climate problem, but to have better homes and overall a better future. And we'll talk about that. So some of the benefits from coaching real quickly is basically the shorthand is we try to help people become more educated consumers. A lot of people don't even know what their furnace is or what their hot water heater is, and much less how to replace it with a better electric version. And so we're here to share information on that, help them navigate contractors, and most of all, establish a plan. There are some other tools for building a plan. We typically recommend starting with an energy audit, and I'll talk about that in a minute. It's very important when you're building a plan, to focus on what your goals and priorities are. And then that plan helps you to be prepared, basically. The key is to electrify before it dies. So you've done some research, you've gotten perhaps some good deals, and you're not stuck in an emergency replacement scenario, which is usually the worst position to be in, both in terms of having hot water or having heat in your home, as well as in terms of having good options. So that's basically what we preach in terms of planning. So that's kind of the coaching part of it, real quickly. So first of all, let's talk about why heat pumps matter. Of course, they matter because we want our homes to be comfortable, heated in the winter and cooled in the summer. But they also matter from a larger point of view of our energy use. So this is a chart from Rewiring America, one of the other courses they offer on why electrify, which I recommend to you. It's a 90-minute course. One of the points that the Rewiring America analysis has shown is that a very large part of the energy-related emissions in our country come from decisions we make in our homes. our cars, but especially how we do our space heating, which is about 40% of energy use. And of course, that translates into emissions when we're using fossil fuels to do that space heating. So that's one of the reasons why this matters. And of course, burning fuels in general for both space heating and water heating is about 60% of our home energy use. And so that's a big reason why heat pumps are important. And of course, it's also, we would argue, important to stop burning fuels inside our homes, which can introduce air pollution and certain risks. So here's where those numbers come from. The Federal Energy Information Administration, that's the 42%, 40% of in average is for space heating, and then another 20% or so for water heating. So that's one of the reasons why this matters. And of course, the other reason is that today, more than half of that space heating and water heating is done with natural gas. So we're burning fuels and creating emissions and sometimes air pollution in our homes when we heat things with fossil fuels. So let me put heat pumps in a broader context of a broader concept called home electrification. And all we mean by that is to replace the things that currently use fossil fuels with electric versions, and hopefully then also power that electricity with renewable clean sources, like you're getting from community solar or solar on your own home, or perhaps wind turbines run by the utility. So this is kind of what a home electrification looks like. As I'll talk about in a minute, we always recommend starting with efficiency, which can be greatly aided by an energy audit. And then there are all the H's here, heat pump water heaters, induction cooking, and solar panels. But today we're going to focus on heat pumps to do the space heating and cooling. So in that context, we're going to talk about heat pumps. One question you might ask is, well, why bother? Well, these systems have been heating and cooling and generating hot water for us for a long time. Well, we would argue that these systems are just better. They're modern, and in particular, much better air quality. I think people have heard about the risks of burning fuels in our kitchens, in gas stoves. Same applies to water heaters and furnaces in your basement or utility room. There are also, of course, safety issues associated with having explosive fuels inside our homes. If you think about it, there is a reason why you should have a carbon monoxide detector in your home if you have fossil fuel systems, because the carbon monoxide poisoning is a risk. We also find that generally speaking, these electric systems provide better comfort and performance overall, sometimes convenience advantages, and they are definitely more energy efficient. And all of these things apply to heat pumps, certainly in addition to the other items that I talked about. So what we mean by the electrification concept is basically just when things are old and you're going to need to replace them anyway, to do it with an electric version instead of an in-kind gas or a fossil fuel version. So that's kind of a normal part of home ownership that we all ought to be planning for. These things do have expected lifetimes. And so that then presents an opportunity to electrify when that system needs to be replaced, and may also generate some operating cost savings because of the energy efficiency they offer. And so planning that in advance goes a long way towards making those replacements not necessarily more expensive than if you just replaced it with another gas version. And for heat pumps in particular, if you have an air conditioner perhaps paired with a gas furnace, and it's at 15 years or more, that's a really good time to be thinking about a heat pump to replace that air conditioner and perhaps the gas furnace as well. And we'll talk about that. So Joel would emphasize one other important benefit of electrification is resilience, which is important to a lot of people, particularly as we find extreme weather perhaps affecting the reliability of the grid more frequently these days, and that's an increasing concern. And so one of the things that is coming, technology that's coming that's very exciting is not just home battery systems paired with solar, which I have, but also so-called bidirectional charging or vehicle to home, where you can actually use that big battery in an EV for backup power. And so you have all electric systems combined with solar and some kind of a battery system, whether it's a home battery or an EV battery, and you have a very resilient home. which also has a lot of benefits for people. So just to finish up in general, the 20th century, we all benefited from fossil fuel systems. I certainly did. But we have better systems now in the 21st century, and we don't need to burn fuels in our homes anymore. And these new modern systems, whether it be heat pumps, heat pump water heaters, or induction ranges, generally speaking, offer energy efficiency improvement a factor of 3, are healthier and safer, and provide better performance. And so now we're going to go into that. But before we do, let me talk about a couple of steps that are important for preparing for a heat pump. And they generally fall into 2 categories. The first is an energy audit and weatherization, which I will talk about, and then making sure the electrical service supports whatever heat pump option you might pursue with an HVAC contractor. So first, energy audits. This is something we always recommend as a first step in home electrification, or even if you're not electrifying your home, it's a good thing to do. It's kind of like the annual checkup with the doctor. It will not only find ways to make your home more energy efficient, but they often also find health and safety issues that ought to be corrected, whether it be improper venting or even sometimes gas leaks. I know one of our clients had a gas leak detected at her water heater. And getting these loads down and understanding the heating and cooling loads of your home is very important, as we'll talk about in a little bit, for so-called right sizing a heat pump. And in general, smaller is better. So if you can get the loads in your home down through these measures, it's going to give you an advantage in pursuing a heat pump.
And Bob, could you just mention how people would go about getting one of those audits?
Yes. So as a general statement, the Building Performance Institute is a good source for most of the energy auditors are certified by the BPI. So if you go to bpi.org, there's a locator there, and you type in your area code, and you can get or your zip code, and you can get a list, and then pair that with consumer surveys to find good ones. If you go to our website, we can also give you recommendations on energy auditors that we have had good experiences with.
Thank you.
So generally, I've seen a lot of these reports, and I can almost write them myself now. They're very, very common things that we see in homes that were built in past years or past decades. And typically, the focus is on improvements in the attic and the basement, particularly where those are accessible, and I'll come back to that point. But there are typically significant energy savings available from things that are relatively easy to do, which fall into 2 general categories. The first is so-called air sealing. So there's a lot of things that are going from your conditioned space below into the attic that have holes in them, basically. So recessed lights are a really bad culprit, but any kind of an electrical or plumbing penetration is going to be letting air and the heated air you're paying for in the winter into your attic and, of course, out into the outside. So air sealing typically comes first, and then a lot more insulation. Here's my attic after it was weatherized, and you'll notice you can't see the floor joists anymore. The floor joists are completely covered, and that's basically what you want to get the R49 level of insulation. And that makes a big difference in terms of cutting down on your heating and cooling loads to help prepare for a heat pump. Most people are familiar with insulation and even know R values and so forth, but the concept of air sealing hasn't been as popular, as well known. And the way I like to think about it is you can have a very well insulated home, but if it's not air sealed, it's kind of like leaving 2 windows open in a well insulated home. And all those little penetrations add up to the equivalent of a window or 2. And you can imagine how much heat you're losing that way. Here's just a little bit of quantification of that. This is a simple tool that we have access to for the same square footage house, depending upon how well it's insulated, either not insulated well at all, or an extremely high performance house like you'd see in a passive or zero energy home. You can see the differences in the heating loads that are associated with a house of the same size. So you can get significant reductions in both your energy use and the size heat pump you would need by weatherizing. Now, in an existing home, there's only so much you can do, but there are typically things that can be done in kind of the low-hanging fruit category to get savings of 15 or perhaps more %. One way it's sort of hard to visualize something like that, but I had an experience. This is my home here on the top, and you'll recall we had the snowstorm in January, followed by 2 weeks of very cold weather. Well, this was 2 weeks later, and my home was still in the north-facing side, was still covered with snow, and all my neighbors had been basically paying, who haven't weatherized their homes, had basically were paying to melt snow on their roofs. So you could kind of see the difference in having done these weatherization improvements. Now, having said that, and being a big advocate for energy audits and for doing weatherization first, and it is usually a good first step, I will say there are cases where that's hard to do, and it may be either very disruptive or expensive in some homes to make the kind of improvements that you can make, for example, if you have an unfinished attic. So that, for example, a finished attic, how are you going to get in there to do more insulation? It could be much more expensive and disruptive. But we would argue that it still makes sense for whatever given heating load and cooling load you have, it still makes sense to do a heat pump. And if you're planning to do some weatherization improvements in the future, there are ways you can estimate the impact of those in sizing a heat pump that you might install today. So while it's important, it shouldn't be an obstacle to deploying a heat pump. So there are some incentives for energy audits and weatherization until the end of the year. These are expiring now. There are federal tax credits for both the audit and the weatherization improvements. And in Maryland, you have some excellent incentives for weatherization improvements that can make it a very good investment. So I'll quickly talk about electrical service before I move on to the heart of the heat pumps here. In electrifying a home, there is sometimes a need to make electrical improvements. The reasons for those can fall into three general categories. First, of course, if you have a very old and antiquated system, you may need to get that upgraded just for safety reasons as well as for other reasons. The second reason is sometimes homes, until they were built in about, I think, the 1980s, didn't necessarily have the current standard, which is 200 amps. You can do it with less, but it's nice to have 200 amps. So that's something that an electrician can look at. And then more commonly, there are usually going to need to be some extra circuits when you're electrifying your home. And whether you have space in your panel or not is another question that might require an electrician to take a look at that. One reason that you may need some of these additional high voltage circuits is if you have a heat pump paired with an electric auxiliary heater that I'll talk about that requires more amps. So those are the two things that we look at to prepare for a heat pump. Now let's get into the heart of it and talk first about what they are and how they work. So fundamentally, an air conditioner is a heat pump, but it only goes in one direction. It only moves heat out of the house and out to the outdoors. Heat pumps do it both ways. They do the heating and the cooling. They will move heat out of the house just like an air conditioner, but they will also move heat into the house for heating purposes. A lot of us tend to think that, air conditioners create cold air. That's actually not what they're doing. They're actually moving hot air out of the house. So that they are, in fact, heat pumps. The other way to think about, and the key thing about heat pumps is, unlike other ways of heating where you're actually creating heat, heat pumps are not creating heat. They are transferring heat from somewhere else using the magic of refrigerants and compressors and some things we'll talk about. And you also have another heat pump in your home. Your refrigerator is a heat pump because that warm air that's coming out the bottom usually, or perhaps the top, that you've probably felt. Well, you ask yourself, where is that heat coming from? Well, it's coming from inside the refrigerator. In fact, it's coming from inside the freezer. So you can get warmth out of even air that is freezing cold. And that's what heat pumps do for your home as well. And basically they're using, rather than using heat or energy to create heat, they're using electricity to power that compressor. And that's one of the magics of heat pumps and why they can do this trick of moving heat around. And that's what's in your refrigerator or your air conditioner. There's a little bit more here. I'm going to leave these charts if you want to geek out. But the key point here is that you might wonder, well, how can a heat pump get heat out of air that's outside that's very cold, colder than I want it to be inside my home? Well, the answer is, in simple terms, is that the refrigerant, when it's going through the outdoor unit, is actually extremely cold, colder than the outside air. And so it's attracting heat into that refrigerant, and then with compression, moving it back into the house in a warmer state. So that's basically how they're working. Here, if you really want to nerd out, is a chart from Rewiring America that you can study at your leisure. The key point I will leave you with, though, is they are very efficient. And you can say, sometimes you'll hear people talk about heat pumps being 300% efficient. That isn't really quite, strictly speaking, quite right. And so there's this term called coefficient of performance, which is the measure of efficiency that's used for heat pumps. And it's basically typically around 2 to 3, rather than 1 that you might get from electric resistance heating. So if you've got sort of, for example, baseboard heating or space heaters, or think of your toaster, they are using electricity to create heat in those coils. And that's going to have an efficiency factor of 1. Whereas heat pumps have an efficiency factor of 2 to 3, depending upon the outside temperature that they're drawing air from. And of course, fossil fuel furnaces are always going to be less than 100% efficient because some of the heat is going up the smokestack. So that's one of the big advantages of heat pumps, is because they are transferring heat rather than creating it, they are very energy efficient. Just to geek out a little bit, you might say, well, how can they get more energy for heating than they're putting into the system? And this chart is kind of a nice way to think about that. It's because they're getting free, quote unquote, heat from outside. So if you look at the BTUs that are being delivered inside the house, of about 30,000 here, only 10,000, only about a third of that energy is coming from running the compressor, the electricity required to run the compressor. The big source of energy, though, is from the energy that's in that heat from outside. Even when it's cold, there's energy there. And so it's borrowing that energy and compressing it using electricity to do that. And that's why it's giving you a factor of 3 in terms of delivering energy or heat into the house.
Yeah, let me just take one quick stab at it.
Yeah,
Like,
Joel.
so if anybody's ever used like a plug-in tire pump or something like that, it basically is pumping air from a lower pressure to a higher pressure inside your tire. And we're fine with that because we can, because even though you can't see air, you have a sense that like, oh, it's inflating, right? A heat pump is sort of the same way, except it's not, it's taking the heat out of the air and leaving it a little cooler and pumping it to a higher temperature, whether that means from inside your house to outside during the summer to make your house cooler, or from outside your house to the inside during the winter to make your house warmer. But it's that same idea. You take a little bit of energy to pump the heat against its normal flow direction from hotter to colder, making it colder or hotter inside your house. And so that's why it's so efficient, because it's not, as Bob said, producing heat like a resistance heater. It's just moving that heat around. And it's very unintuitive, but they are pretty amazing devices in that they are able to create a temperature difference using a relatively little amount of electricity.
Thanks, Joel. And that it's good that you mentioned that compression part of it and pumping up that air, because that's where modern heat pumps have made so many advantages or advances, is in the efficiency with which those compressors operate. And they're now all computerized, and that's one of the ways we're getting better heat pumps than we had in the past. So I mentioned before that electric systems tend to be more comfortable, and that's true of heat pumps because they do heat differently. Whereas a furnace tends to have these red lines. It gets below the set temperature and it blasts a lot of hot air up to about 120 degrees typically, and then it goes off for a while, and then it goes on again. Heat pumps tend to be blowing out warm air, not hot air, perhaps about 95 degrees on a more steady basis. So you're going to keep the temperature more steady, uniform over a period of time. So that's one of the reasons why they do operate differently. And most people consider that way of heating more comfortable.
That's a really helpful visual. I hadn't thought about it that way.
Yeah, thank you. Okay, so let's now get inside the box. So we've got the outside unit and the inside unit. And a lot of the magic goes on in the outside unit, where you have this compressor that Joel was just talking about, and they're now very advanced systems. And of course, you have a heat exchanger and a fan, some other items out there in that outside box. Well, let's talk about types. And now we'll get into the heart of the actual heat pump. So in terms of an overview, again, just to remind you, they're transferring heat, not producing it. That's how you get these high efficiency factors or coefficients of performance. It's both a heating and a cooling system, and they're, by the way, very good air conditioners. And they work well in cold weather. I will come back to this, but most high quality heat pumps now will work very well down to the teens, basically. And there are heat pumps, so-called cold climate heat pumps, that will work even temperatures even below that are being deployed in large numbers up in New England and other northern states. And it's also possible, as I'll show you, to supplement that with an electric resistance heating, as Joel was mentioning. They are available in lots of different outside and indoor types, and I will show you those. And they also come in different sizes, which is typically referred to in tons, and I'll come back to that. And again, this is the largest source of energy use and emissions in your home, and if you're interested in your climate impacts. So let's start with the exterior units. As you can see over the photos on the right, they tend to come in either vertical or horizontal types. They're doing the same thing, they're just doing it a little differently. Until recently, most of the North American manufacturers tend to have the vertical and the Asian manufacturers the horizontal. I think that's partly because the North American manufacturers, were kind of building off of their experience with air conditioners. That compressor out there is one of the key things that's going to affect both the efficiency and the cold weather performance. So the top compressors now are so-called variable speed compressors. In other words, they're not just on or off, but they can operate at different levels and therefore be very energy efficient and also good cold weather performance. Sometimes you'll hear those called inverter-driven compressors because the compressor is actually controlled by a computerized inverter system. So if you look inside these, they actually have circuit boards that look like a computer, the modern ones. They are efficiency ratings for both heating and cooling. You'll hear these phrases of HSPF2 and SEER2. Good ratings these days are in this range for heating and in this range for cooling, sometimes higher than these even. And they are connected to a variety of different ways of distributing the heat and cooling inside. And so we'll come back to ducted and ductless.
Bob, just to clarify, are you saying if you're looking for a heat pump, you should look for these scores, or just that's the range that heat pumps come in?
So so all heat pumps will have these ratings and be on the energy guide. And what I'm saying is these are kind of the top end of the range these days. There are heat pumps that are below these ratings. These are kind of good scores, I'll call them.
Thanks.
Also, just those scores tend to come with those variable speed or inverter driven. And just one thing about those inverter driven ones is that they don't just go on or off. They have a little computer inside that lets them go much faster or slower than as needed. So essentially, it can match the outside temperature better than the on-off ones. And so the inverter-driven ones are the more efficient ones, and that's how you get these higher scores.
Yes, and one of the reasons they're more efficient is because going on and off tends to use a lot of energy as opposed to running continuously at a low level. Okay, so that's
it also tends to make your house more comfortable.
Yes.
One analogy is like it's like dumping a bucket of water onto you every time it comes on. For the on-off ones versus like a gentle shower that sort of is constantly sprinkling water on you with either more or less as the situation needs it. So, you don't want to shower with a bucket usually.
Right. Okay, so that's the external units where a lot of the magic takes place, but they also have to have a way of distributing that heating and cooling inside your home. And so there's basically two different ways of doing that. And you'll hear reference to ductless systems, sometimes called mini splits, which is kind of a weird term, but that's the term of art, or ducted systems that use the duct system in your home and generally can replace an existing central air and furnace combination that's very common in our DMV region here. And they tend to look very similar. Ductless systems tend to be a choice for homes that don't have ducts, either because they had boilers and radiators for heating or baseboard electric. And we'll talk about each of these in turn. But that's kind of the big picture. So starting with ductless, or again, what's sometimes called mini splits, rather than distributing through a duct system, because the home doesn't have one or doesn't have a good enough one, it's distributed directly from these internal units. Now, there's several types of them, as you see in the photos. The most common you'll see probably these wall units. You see a lot of those over in Europe, for example. Sometimes they have floor-mounted ones or even ceiling ones, and now even some that look like other things, like pictured. So who knows what will be next? And they're, again, typically used when the house doesn't have ducts or adequate ducts in these kinds of situations. And an outside unit, like the ones we showed before, will be supplying one, in some cases, or more of these internal units, depending upon the particular type of mini split. And the refrigerant lines will run from that outdoor unit to these indoor units. Sometimes it's just the outdoor unit might be on the other side of the wall that this wall unit is mounted on, for example. So it's a very short run for those lines. But that depends on the house. So I'll just mention one that's kind of cool. And the terminology tends to get even more convoluted, perhaps, is that there's a variant on mini splits called so-called ducted mini splits, or sometimes other names as well. But it's basically, instead of having that wall unit, there's a small air handler. Might be, for example, in the attic, supplying heating and cooling to bedrooms below. And then there's short, flexible ducts to supply a number of rooms below it or nearby it. This is often a good answer for bedrooms where they're relatively small rooms and you don't need a big heat pump for each room. This is a way of distributing the capacity among a number of small rooms. So that's another variant on ductless, but it's basically providing ducts for a particular localized area when they didn't already exist in the home. So there's a lot of variants of these things. So turning to ducted systems, again, it typically will replace an existing system that may look very similar and have a very similar footprint. In my particular home, it was almost identical, and it uses the existing duct system for the air distribution. Now, this can be an issue, and I'll come back to this, is to the comfort and effectiveness then depends upon how good your duct system is, and that can be something that you need to have looked at. But basically, the air handler with a fan is transferring the heat that's being dumped into the air handler from outside through the duct system. Now, one of the nice things about these systems is you can add a so-called strip heater, or sometimes called auxiliary heaters or resistance heaters, in the air handler to supplement the heat from the heat pump itself. You can also add filters and humidifiers to these systems very commonly. Here's mine. And as you can see, there's my old gas air conditioner, gas furnace with air conditioner. And the heat pump is, you might have trouble telling the difference, except we don't have these, we don't need these exhaust pipes anymore. But otherwise, it's pretty similar system, same space, same air filter, and so forth. In my case, I do have one of these auxiliary heaters, which I'll come back to that. One thing I'll note here is if you are getting proposals for heat pumps from contractors, it's always a nice idea to ask them for the AHRI cert or reference number. That defines a unique combination of an indoor and outdoor unit, so you know exactly what you're getting. And you can also look in databases up the specs for those. We can come back to that though. I mentioned before the efficiency ratings. These are mine, which is this is one of those so-called variable compressor or inverter-driven compressors. So you get the nice, good heating rating and an excellent SEER rating for air conditioning. This is what those electric resistance things look like. They're inside the air handler, so you can't see them, but they're basically big coils that heat up kind of like your toaster. They're kind of like a giant toaster. And the nice thing about these is they can supply heat irrespective of the temperature outside, but they do use a lot more electricity in the rare occasions when they're needed. I will say, as by way of passing, that if I knew now or if I knew then what I know now, my system is probably over-designed with 20 kilowatt system. So I mentioned that ducts can have a big impact on the effectiveness and comfort level provided by a system in a ducted system. So that's one thing a good contractor should look at is the size and condition of the ducts, because airflow really matters. And if you have poor ducts or poorly or ducts with lots of leakage, you can get very poor airflow. For example, up in the second floor bedrooms that are furthest away from the air handler. So they're often leaky at joints and corners. There often wasn't a lot of attention paid to that when homes were built in the past. Can have a big impact. So that's something that should be looked at. And there is an option for dealing with that, so-called aerial seal, which I had done on my home, that makes a huge difference in the airflow. I'll leave this with you, but this is basically the AeroSeal process. And there is a very nice video on This Old House that explains it quite well if you want to know more about that. There are other ways to treat ducts, of course, as well, if you have access to them and can seal them and insulate them directly, but this is a good option for ducts that are within the walls that you can't get access to. So I'll mention before we move on, there are two other kinds of heat pumps. I talked about ducted and ductless heat pumps, but those were both providing air, the heating and cooling via air. Of course, a lot of people have boilers and radiators. So there are heat pumps that are so-called air to water heat pumps. So they are, again, taking that heat from the outside with an outdoor unit, but then putting the heat into a water-based system and distributing it through with pipes through radiators. These are interesting technology. They tend to be more popular now over in Europe. There aren't very many people doing this yet in the US, but it can be an interesting technology for people who have radiator systems and like that form of heating. There are also some systems that can also provide domestic hot water, so you get kind of a single system that does both. Interesting technology, but right now less common in both the US and in our area. And then the other one that is more common, in fact, up in Maryland, we hear a lot about so-called ground source, or sometimes called geothermal heat pumps. Here's a little information on those from the Rewiring America course. The good thing about those is they're kind of the ultimate in heating efficiency, because they are drawing that heat from the ground temperature rather than the air temperature. And the ground always tends to be around 50 degrees. It doesn't get as cold as the outside air. And so it's exchanging heat with air that is not as cold or not as hot in the summer. And so they tend to be very energy efficient. But they are expensive, and they can be disruptive because there's a certain amount of drilling and digging that goes with installing them. And generally speaking, they're best for either a new home or a major addition. And also because air source heat pumps have gotten so good now that it's harder to justify the cost.
And Bob, just a time check, we're
Yes.
around 12:50, so I just want to make sure we have
Yes.
time for questions, so just
Yes.
keep that in mind.
Thank you. I will go quickly through this so we leave time. So HVAC capacity, whether it be a heat pump or a furnace system, they're all BTUs, but they just do it differently, but they're doing the same thing. You're going to talk about BTUs per hour, and typically those are in the thousands. And then so often you'll hear that talked about in terms of tons. So a ton is 12,000 BTUs per hour. So for example, a very common system might be a 4-ton system, which can provide up to 48,000 BTUs per hour. So that is something that needs to be looked at carefully in a heat pump system. To make a long story short, good HVAC contractors should do some kind of an estimate of the heating loads of your home. And those are based upon the location of the home and how cold it gets or how hot it gets, which is the so-called design temperature. And so that's an important factor in getting a heat pump installation done right, is to get the sizing right. You want it enough capacity to keep you warm when it gets cold, but not too large, because larger systems are not as efficient and tend to be to cycle. Here's a quick diagram of there is a lot of heat pumps that aren't done well. Various surveys have shown that are either too small or more commonly too big. You want to get it in this right sort of Goldilocks range here in terms of the sizing. And the problem again with too big is it can be both energy inefficient. It can cycle on and off a lot, which is hard on the equipment, and it's not going to be as effective in humidity control in the air conditioning mode. So that's why getting the sizing is important. And I'll leave this for you to look at later. This is kind of a very insightful chart if you spend some time looking at it. But basically, this is the home heating load, which basically obviously increases as it gets colder outside. You need more heating capacity to keep it warm as it gets colder. And then the heat pump will provide heating. And at some point, all heat pumps are going to start to lose capacity at different temperatures. Cold climate heat pumps will continue to supply heat, even down to 5 degrees or below. But basically, you want to get it so that your heating load at whatever the design temperature in your region is, for me, it's 14 degrees, is about equal to the capacity of the heat pump at that temperature. So that's kind of what you're looking for in terms of getting the sizing right. Let me quickly mention cold weather, which is a big concern for a lot of people. I was certainly concerned about this. Older heat pumps did not work well in cold weather, and that was my experience in 1985 with my condo, where it was very cold weather that day, and we froze to death with that heat pump. A lot of people's impressions of heat pumps are still similar with that to that. One point to keep in mind is that we do need to worry about these low temperatures, but most heating, even in the winter, is actually done in the 30s, 40s, and 50s. So while it's important to have a heat pump that does handle the coldest weather, they're champs at the more common temperatures. The other thing to note is that with climate change, those extreme cold conditions like we had in 1985 just aren't happening as often anymore. And so we don't need to worry about it as much. But it can happen, like the polar vortex last winter, where it got down to 15 degrees, which is about the design temperature, as you see here. And that's where these electric resistance items can come in handy, either that or a cold weather heat pump. But even when it got very cold, for a few days, my system was using these electric resistance backup, and we were nice and warm and toasty, even with an all-electric system.
So you can still get a heat pump if you live somewhere cold. It just needs to be specialized for the cold. Is that right?
Yes, there are two ways of dealing with that. Around here, a good heat pump will handle the vast majority of the temperatures. You can either supplement it with these electric resistance, or you can go with a heat pump that operates effectively even colder weather than my heat pump. Or you can pair it with a gas furnace and have the gas furnace kick on only on those very rare frigid temperature conditions. But my point here is there is an all-electric solution if that's what you're looking for. We're going to run out of time here. So in terms of maximizing efficiency or affordability, again, the point I made earlier is do your research ahead of time so you have a chance to shop around for both brands and contractors and get the best deal rather than operating in an emergency replacement scenario, which is not the greatest way to get a good deal. I'm going to look for the one on contractors, and we'll finish up there. So there is a way of calculating, I'll leave these charts with you, of how much it will cost to operate a heat pump. The short version is that with today's natural gas prices, it's about the same to operate a good, efficient heat pump as it is to use a gas furnace. And let me go now to where's the contractors? Here they are. So I'll finish with this and leave time for questions here. There are some keys to finding a good contractor, one of which is, of course, to make sure they have experience with installing heat pumps, getting that sizing right, as we talked about, measuring the airflow, making sure the refrigerant charge is correct. Some of these things that go into proper installation of a heat pump. This is one of the things we try to help people with in our coaching is, marrying them up to good contractors depending upon what they're looking for. The manufacturers tend to have lists of qualified contractors on their websites, and then cross-referencing that with local rating services is another way to find good contractors. Joel, do you want to add anything to that before we finish up and take questions?
If you find a contractor that says that heat pumps don't work or they, move on. I like to say, yeah, if you think that heat pumps don't work because you had one in the 80s, like Bob was talking about, I like to say I had a computer in the 80s, and relative to today, it didn't work very well. The tech's much better. There are contractors out there who have embraced heat pumps, so go find one and have asked them to do a manual J and to do a good job. I will also say on the manual J, you could try offering to pay them separately if you're interested, like maybe like $500 for them to do the design or to include it in the actual as part of the cost. But you do want to try and size it properly, and the manual J is a standard way of assessing your house and trying to right size the system.
And just to add on that, one of the it's understandable that contractors don't necessarily want to go to the time it takes to do a manual J for just a proposal to you that you may or may not accept. But it is reasonable, I think, to ask them to do that after you have a contract with them and they're going to buy a heat pump from them, and then make sure they're sizing it right by doing a careful analysis of your heating loads. So with that, we'll stop there and see what questions people have. Over to you, Stephanie.
Thanks, Bob. I learned a lot, and I hope everyone else feels that way too. Let's go ahead and if people want to unmute themselves, or feel free to ask questions in the chat if you're more comfortable doing that, and I'll read them out loud.
Thank you.
Hi, my name is Aaron. I asked a question in the chat. We're in Maryland and we have an old heat pump. It's probably 15 years-ish old. And we also have oil backup, and the oil tank is in our basement. And I think I've seen or heard that it can be prohibitively expensive to remove oil tanks from basements. Do you have any recommendations? Like if we were to get rid of it, should we just leave it there, or what are your thoughts?
I had an oil tank removed from my basement, and it was like $1,100, and it was a fantastic uh, thing that to pay for. We bought this house a couple years ago, and the basement always smelled weird, and and it was hidden behind a couple of sheets of plywood that I hadn't looked behind. And when I finally looked behind it, and I saw the tank there, and I contacted somebody. I could try and find the name of the people who did it, but it was $1,100. They came with a grinder. They grinded the cover off. They scooped out five-gallon buckets worth of crud that had been there probably for decades, and then they removed the whole tank. And it was the best
Wow.
$1,100 I spent. It took them like 3 hours, and the basement no longer smells.
Wow, yeah. If you have any of that information, I'd love to get it.
And as we talked about, it's definitely possible to get a heat pump that doesn't require that fossil fuel backup.
Yeah, we don't want to keep the oil tank.
Yeah, good. Thanks, Joel. Other questions? And I'm sorry, I didn't see the chat as we were going. So if there were questions in the chat, if you want to repeat those now, that would be great.
Yeah, sorry, I missed your question, Aaron. Thanks for asking that. And Joel, if you end up sharing the resource, please share it with me as well. That way I can send it to everyone if other people are having this issue too.
So this is David. So Bob, what you're suggesting is when we get several bids from HVAC contractors, they may not do the manual J until afterwards. In other words, they may ballpark their proposal to us and then afterwards do the manual J.
Right. Yeah, when I did my heat pump, I had 7 proposals, which was maybe a little overkill, but not one of them offered to do a manual J. In fact, they didn't even mention the term. And other people I have talked to have had similar experiences. And I can understand that because there's a lot of time involved in preparing one. And for them to do that for a proposal that you may not even accept is totally understandable. And also, I would say they're generally pretty good at estimating. So they can look at your house and its condition and the comfort issues that you identify and say, yeah, this is probably a 4-ton system. Um, and they're probably about right. But from my point of view, a good check is to, in the contract, ask them to verify that with a careful load analysis, as part of the work after you accept a contract with them. Because then they're
And
not doing a manual J for you for free. They're doing it as part of the project itself that you're paying for.
Do they have to do a blower test, or do you know if they have to do a blower test as part of Manual J, or can they use the previous blower test?
So a good manual J will have the air leakage metric as one of its key parameters. So you need that from somewhere. Um, Now an energy audit will provide that. So if you have had an energy audit, you can give them the air leakage metric. Um, Again, because I didn't have any Joel might want to weigh in here, but I didn't have any contractors who offered to do a manual J, so they certainly didn't offer to do a blower door test. Um, I don't know. I have not encountered any contractors who offered to do that, which is another reason why it's a good to do an energy audit to get that information. Joel, do you have anything to add on that?
Yeah, I think, as Bob said, one good thing to do is get an energy audit with a blower door test, and that will give you your house leakage number. Then when you do the manual J, because as Bob was saying, so much heat and cooling, I suppose, is lost to the all the air holes in your house. They put that number into the manual J in order to calculate what the quote unquote load is. The load is basically how much heating or cooling does your house need in winter and summer. I should also add that I've been going very slow, and part of me has been trying to like figure out the process as deeply as possible to give people advice. I actually hired a company called Energy Vanguard based in, I think, Georgia, to do a manual J for me. And I think it ended up being like 2 grand. So that's like a pretty expensive manual J from professionals. But like, um, it's not just manual J. There's other, and just so people are clear, when they say manual, it comes from a physical book that was the manual on how to calculate the load, and they used to do it by hand. Now they use computers to do it. There's other quote unquote manuals as well. There's also manual S for sizing the equipment. There's manual D for duct design. There's manual T for the register design. And they did all these things for my house. So now I have a design for 2 grand. 2 grand obviously is a lot of money just for a planning thing. But at the same time, now I can go to a contractor pretty confident in what the numbers are and be like, this is what I want you to implement. And I don't necessarily recommend you do that. It is an option if you want to. But trying to find a contractor who's going to do the load calc and figure out what a good size system for your house would be is a good first step. If you do have existing ducts, you do want to make sure that the ducts are in good shape and find out from the contractor whether the ducts are going to work for a heat pump, because sometimes the heating load is greater than, particularly in the DMV, the heating load will be greater than the cooling load. Even though it seems like we have very hot summers, you only cool your house from like, let's say 90 degrees down to 70 degrees. Whereas in winter, you might have to heat your house from 30 degrees up to 70 degrees. So it's really that temperature difference that defines how much the load needs to handle.
So another
And
option
Joe,
on the experience that Joel described of his own is there are some companies, not as many yet in this area, that do sort of a whole home integrated approach to electrification. And so they will do an audit for you, and they will also, propose an HVAC, a heat pump system for you, and perhaps a heat pump water heater as well. And in that case, you may get that kind of analysis that Joel was talking about as part of their overall service. There's a company, I know in Colorado, they have Elephant Energy, is that kind of a firm. Abode Energy does that up in Massachusetts, Abode Energy Management. So I'm not aware of too many yet in this area, though.
We've got one other question from G Lockwood. I couldn't see your first name, sorry, but asking about the HERA, HEEHRA program that got started during COVID and was offering heat pumps at reduced prices for low-income homeowners. And apparently there has been no additional word about that. Joel or Bob, do either of you know anything about that program?
Joel, you want to take that one?
Yeah, I'm. So this is these are the Inflation Reduction Act um, ta rebates. They're tax credits basically. Um, HERA and homes, it wasn't exactly low income. It depends on the state. So basically, what happened was, the new administration came in and they canceled a lot of that stuff, and both initially some of the low income stuff got canceled out of grants, and then Congress, with their big beautiful bill, repealed a lot of the tax credits from the Inflation Reduction Act. That said, let's see. Maybe I'm mixing these things up. Maybe I'm saying the wrong
Yeah,
thing.
so let's,
You're
so
right. Here, I think Maryland got one of them in. I don't know. Do you know?
so
I'm not up
DC
on this.
so DC got there. So the problem was that there were tax credits in the Inflation Reduction Act, and those went into effect immediately. There were also appropriated funds to provide rebates that were administered through the states. And there was a long process during the Biden administration of the states getting approval from the Department of Energy for each of one of their programs. And most of them didn't make it before the end of the Biden administration and the transition to the new administration. So DCs were approved and in place. Virginia does not have them yet, and Maryland, I don't think, has them yet. There were some questions about whether that appropriated funds would be clawed back by the new administration or not. And there's, as far as I know, still uncertainty about the release of those funds and therefore the availability of these rebates. They were targeted, as Joel said, on low and moderate income. Although in this area, those are pretty high income levels, like 130,000, I think, for a family. So those were significant incentives to deploy heat pumps and heat pump water heaters and other items, but their status, other than in DC, is uncertain right now with the current administration's policies.
I might add that yesterday I was at a conference for HVAC contractors and the Maryland Energy Administration. The Maryland Energy Administration basically was saying, we have money for low and moderate income. Please use it. Please come to us. We've got money we can't spend.
Okay,
And
good.
that was a major theme of this conference. Please use these subsidies.
Okay,
Um,
good.
I'm just going to share a link to just an energy.gov site where it
Yeah.
seems like you can check rebates because I'm seeing a lot of different resources, but I'm not sure what's most up to date. So this is likely the most, like the best one to trust if you
And
want
also
to.
to go to your own state website for the current
Yes.
status of your state's program.
Yes. And then I saw also, G. Lockwood, that you had mentioned getting an energy audit through BGE. And I also see another question here from Sheena, who also got an energy audit. Well, maybe not through BGE, but using a business on BGE's website. So I'm going to go ahead and read the rest of Sheena's question, but I am curious both from Sheena and G. Lockwood about your experiences using the utility to recommend someone to do the energy audit and how that process went. But I'm going to go
I
ahead
might
and,
comment
yeah.
in Maryland, if you use the Empower Fund through BGE and they do a blower audit, they come up with one number, they come up with a target, and in order for the contractor to get paid by Empower, they have to meet the target on at the second blower door test. And I saw weatherization crews do extra work. The worker said to the supervisor, hey, we're not going to meet our number unless we do the game room and put foam in. And they knew what they were doing and they made sure they got to the lower number and they could send the documentation to BGE so they would get the contractor would get their share of the money.
And I worked with David on his, I believe it was your daughter's house. And there were also significant rebates from that program in
Right.
Maryland.
Ecomise is a contractor you can use in the Baltimore area that did the whole picture and had a very professional approach to it. And they made sure that they got paid, that they got their share of the deal paid by
And
the
with the
Empower
kind of rebate, with the
Fund.
kind of rebates that were available from that program, it was a no-brainer to do the work. because you would pay it off very quickly because so much of the upfront cost was covered.
Thanks, David. And Bob, I'm going to go ahead and read the rest of Sheena's question, but thanks for adding that note because that sounds really important to know if that's the only way to get funding. So Sheena said, I got an energy audit using a business on BG's website. The gentleman who seemed knowledgeable and credible, he said after insulating our attic, we would notice the difference. When it came time to do the work, he subcontracted the work to some crew. While he showed up before the job started, he had no part in the work and he did not physically inspect the work. I didn't notice any difference in the temperature in our top floor in hot or cold weather, and I wonder if the work was properly done.
Well, it's hard to know, from the exact situation of that home, but I guess I'd offer two things. First, they should have done a before and after door test. So in other words, the initial audit should have had one, and then after the air sealing was done, they should have done another blower door test to see if they actually reduced the air leakage for that part of it. And that should have been provided. I know in my case, I got the before and after numbers. And in fact, those had to be provided to Dominion in order to get our rebate from Dominion. With regard to the insulation, if they were doing work up in the attic, you ought to be able to go up and look at it. And again, the key thing to look for is, are the floor joists completely covered with insulation? You should not be able to see floor joists if you have, enough sufficient amount of insulation, both in terms of providing that R factor and also eliminating the so-called thermal bridging through the floor joists that can leak air warmth into your attic. So those would be a couple of things to check. I don't know, Joel, do you have anything else to add?
Yes, it is a challenging thing. You can ask questions of your contractor, like who's going to do the work? Are you BPI certified? Are you BPI Gold Star certified? I think is like the higher level of training.
Yeah.
You check the reviews of the people, both, you could check on Yelp or on Angie or on Google Maps, has reviews for businesses. You can try and filter them by, if they have 100 5-star ratings, they're probably going to do a good job. If they have two, 3-star ratings, you might want to find somebody else. And so you're kind of looking for this, you're looking for like BPI certified is good, or NATE certified, NATE is another like, like for house, I forgot what it stands for or whatever. You're looking for good reviews. You're looking for a certified by the utility if you're hoping to get some money back from a utility program. I made a spreadsheet that tried to lay these things out. Even then, it can be difficult to ensure that it's a quality install. For an attic, attics are sort of the best place to direct your air sealing and insulation goals, in part because uh, they're often quite leaky. They often reveal big holes into the house that can be stopped and air sealed. And because the heat rises in the winter and leaks out the top, if you can seal and insulate the attic, that stops a lot of that. But, in an ideal world, and this is not very uncommon, I think, the contractor goes in, they remove all of the insulation from the attic. Then with everything exposed, they can identify those big gaps, and some of the holes can be very big in your attic. And they can identify all the little cracks and stuff that they seal up, and then they can add the insulation back on top of that. And so it's the kind of thing where, yeah, it's tough to QC, to quality control the job while it's being done. But if you've done the work ahead of time to try and find a contractor who has good reviews and is certified by some third party, and then you do a little bit of monitoring during the job where it's like, hey, they didn't vacuum out the attic, so they just laid a couple of new pieces of insulation on top. Is that what I paid for? I don't know. Probably not. And then you could bring it up with the contractor. It's really even harder to do in process, but this is the reality that we're dealing with. Like the best you can do is to try and make sure that the person who agrees to do the job is qualified and is going to do the job that they said they were going to do. And as Bob said, the blower door will not lie. It will tell you how much the air leakage has been reduced. And so you could even put that into a contract where it's like you're going to reduce it by 25% or 30% or 50% or whatever they think is reasonable. And then you have a number and you can ask to see the number. Prove to me that you've hit this goal. And like David was saying, it's possible that the utility rebate programs have numbers that they require in order to pay out the contractor, and that's another check. But these things are difficult. It is possible to I don't know who, but there are I think there are people who will provide consulting services. That's a next level kind of next level step is like you have your own QC person checking up on the contractor. I have not done that myself, but I might do that for my HVAC.
Just say, I'll just add to what Joel said. I agree with everything Joel said, but for a audit and it's already happened. I mean, I agree with Joel's comments about how to find a good one, but given where you are, if that energy auditor arranged as part of his contract, the subcontractor to do the work, he ought to be responsible for whether that work was done properly or not. And you ought to be able to follow up with him and say, look, this didn't provide the results that you indicated. I know when I had my energy auditor, who I was very happy with, did have a sub to do the weatherization work that he works with. And there was a glitch. It was just a misunderstanding. And I went up to the attic and I said, wait a minute, you didn't do this. And I called my energy auditor and he immediately had them come back. And in fact, they went out and bought some more bad insulation to fix the problem. And so, I held his feet to the fire and he came through. So your auditor ought to be able to come, make sure the blower door test was done after the fact and make sure the wet insulation work was done properly.
Yeah, it's good to have hard numbers and goals that you can hold people accountable to. So I think that's great advice. There's one more comment from Sheena in the chat that I'll just read out loud here. So Sheena said, getting newer appliances sounds like it should be a good idea, but when we got a new energy saving dishwasher, we found the older appliance clean better. We even used the recommended detergent. A related point, it seems many folks are finding appliances aren't made like they used to be. They don't last as long and you have to replace them sooner than you would have had to in the past. And this seems to be by design. This is not good for the environment either. I completely agree, Sheena, and that's really frustrating. There's actually a word for it called planned obsolescence that blew my mind when I learned about that, and the fact that businesses are intentionally designing things to break, so you have to buy another one, and then they also don't make them repairable, so you have to buy another one. You can't fix it yourself. So I couldn't agree more on this point. And often, the most sustainable item is the one you already have that you can use until you can't anymore, and then you get a more sustainable one. But I think when it comes to appliances like this, based on what Bob and Joel were saying, the newer heat pumps, it sounds like, are much more effective than the older heat pumps. So I'm not sure if that statement necessarily applies in this case, although I think it is generally applicable. So I'm curious what your thoughts are, Bob and Joel.
Yeah, on the let's do the appliances and then the heat pumps. On the appliances, I agree with all the comments there. And I would just say check consumer reports because they do track brand reliability. So try to go for a brand that has a better reliability track record. On the heat pumps, I'll just say a couple of things. First, they do tend to come with 10-year warranties on the parts. So that's some comfort on that point. And then one thing you can do on the negotiations, particularly if you're getting one about this time of year, when the so-called shoulder season, when there's neither a lot of air conditioning nor heating going on, the installers tend to be a little more looking for business and negotiable. And so one thing you can ask is for, how long is your labor warranty? So maybe they'll usually offer you a year, but maybe you can get a 3-year, 5-year labor warranty to go with that 10-year parts warranty from the manufacturer. And so that gives you some assurance that even if there is a problem, it won't be your nickel.
Yeah, to that point, you are correct in that to some extent, appliances are not as, robust as they used to be. To another extent, it depends on the manufacturer. German and Japanese manufacturing is generally considered to be higher quality. I personally so far have gotten a LG induction stove So I replaced a gas stove that was not dead yet, but I wanted induction. We got this LG stove. I bought it from Costco, which, in addition to the 1 year LG warranty, had another year, so a 2 year warranty from Costco. And there's really very few moving parts in this induction stove, except for some cooling fans. And we've had a couple of problems with the cooling fans, and I've called warranty service, and they've come out to service it. And that's going to end soon because I'm almost at 2 years, and I'm like trying to get it repaired before the end of the term. That said, it's worked pretty well, other than these small problems. And this isn't so much a question of electrification or switching over to electric appliances as it is trying to find the stuff that has a better reputation and hopefully is going to last.
This
And
is the best.
like Bob said, trying to find better warranties. Um, my hunch
Home
is that after things
electrification.
last for the first couple of years, they'll probably last for the lifespan. Um, Heat pumps are coming with 10 or 12-year warranties for parts. Doesn't cover labor necessarily, but it is negotiable maybe. And yeah, I mean, there's not a great answer other than to try and do your research and try and maybe spend a little bit up front to try and get a higher quality appliance than the lowest end stuff. And that can be hard to pony up the cash up front, but um, but when they work great.
I'll add that Consumer Reports does do reliability ratings, not just on refrigerators and dishwashers, but they do them on heat pumps too. So you can look and see which brands have the better track records.
Good to know. Thanks. I'll include that in the email as well. And then I see we have one more question from Tony Rodriguez asking, is there an electric cost trade-off point where the cost of electricity is so high that it is not economical to use a heat pump instead of a typical gas heating unit? Is there an online analytical tool that can be used to make this determination?
Yeah, that's a really great question. So the the cost trade-off in operating a heat pump versus a fossil fuel furnace does depend upon the local prices for both electricity and the fuels. So there are some cases that are easy and some cases that are more debatable. For example, in New England, where they have a lot of home heating oil or propane, those are very expensive fuels. And it is, even with high electricity rates, it's kind of a no-brainer to save money with a heat pump. Here in the DMV, where we have pretty cheap natural gas prices right now, and at least in Virginia, reasonable electricity prices. As I said before, it's kind of a wash between the cost of operating the gas furnace versus operating the heat pump, about the same. There's some slides that I didn't go over in my deck that talk about that. And so you can do the math yourself with putting the gas price and the electricity rate. In Maryland, I think you're more like 19 or 20 cents a kilowatt hour versus 14 to 15 here in Virginia. So, electricity gets a little bit more expensive. One really, to me, the best answer to that, to bring it back to the beginning of this talk, is solar. Because one of the great things about solar power to power all these electric systems is not only is it probably cheaper in year one, but it's never going to go up, at least if you have your own solar system. So you pay to install that solar system as I have, and I've got effectively a rate of about 12 cents a kilowatt hour for the life of that system. And so the Dominion rates can go up, and I don't care. And my solar rate is still powering that heat pump and my other electric systems. So that to me is one of the best ways to get some protection from rising electricity rates, which are an obstacle to electrification. I know in California, they've got, 30, 40 cents per kilowatt hour rates. Same thing in Massachusetts. And so that is definitely makes it harder to make the economic case for heat pumps and other electric systems. And that's why solar is such a good deal. I don't know, Joel, you want to add to that? You wrote the book.
I don't know of an online tool that lets you compare the rates. I mean, I think Rewiring America's home electrification planner personal electrification planner. I don't know if it does that calculation.
Oh, I've got one. I've got one. So I discovered a new tool called Thermentor.
Put it in the
So
chat.
THERMENTOR.com. Thermentor. And you can put in your gas usage and your location, and it will tell you how a heat pump costs compares to a furnace cost. So there's one.
Well, there you go.
It's a really cool tool, very easy to use.
Yeah, I mean the operating cost, particularly if you have solar, it can be a really good deal. The solar. One way to think about solar is like you're paying your electric bill upfront for 25 years,
Right.
and the price will remain fixed. So it removes you from, there's a big story now about rising electricity prices nationally, and you sort of insulate yourself from that. But solar is also a big, expensive upfront cost that you can get a discount on if you do it before the end of the year, but we're running out of time because the federal tax credit is expiring. Um, Another way to think about it is it can be a harder sell to be like, hey, you should get a heat pump to replace your furnace, to replace your boiler, to replace your winter heat. But another way to think about it is you should get a heat pump to replace your air conditioner if you have one now, because it basically gives you a second capability of heating your house beyond just cooling your house in the summer. And even if it doesn't do the full 100% of your heating load, it can take a lot of the heating load in coming up now, October, November, part of December, maybe not January, February, but March, April, May, even, these shoulder season months where it's cold out, but it doesn't really need a furnace burning, 100,000 BTUs an hour. Instead, you can use a heat pump, which is producing, 18,000 BTUs an hour and get most of the heating that your house needs. This is sort of related to, but to what Bob was talking about, like, get a manual J for the heating load of your house. That's the full heating load, and it's designed for the 1% of the year that is as hot as it gets and as cold as it gets. That's the full heating and the full cooling load that the manual J produces. But the fact is that most of the year is not at the 1% hottest and coldest time. And so if you replace your air conditioner with a heat pump, or if you don't have an air conditioner now, you want to get an air conditioner, get a heat pump. One analogy is like we wouldn't get a car that only drives in reverse. You need to go both forwards and backwards. And it's the same thing with a heat pump. Get a heat pump instead of an air conditioner, and you can take the load away from your fossil fuel appliance. And then those questions of like, oh, well, is it economical? It'll be economical to do it maybe outside of those coldest times of the year, particularly if you're not running what Bob was talking about, these backup heat strips that they're called. They're basically like a toaster oven that are producing heat, that aren't just pumping heat from one place to another, that they installed to handle those extreme temperatures, as Bob was also saying, aren't as extreme as they used to be here in the DMV, at least. Colorado, different story.
I'm glad you mentioned
I
the air
might,
conditioning, Joel, because the other point to add on to that is um, the modern heat pump replacing that older air conditioner is also going to save you money on air conditioning because that's all electricity. And I noticed that I had a pretty good Carrier air conditioner when I replaced it with a heat pump, but this new Sear 20 heat pump I have, oh my God, it's unbelievably efficient at air conditioning, effective and efficient. So I'm also saving some money on my electric bill in the summer, even if I'm not necessarily saving money on heating in the winter. And to put an exclamation point on Joel's point is that the analyses that you do see tend to show that the cost trade-off varies by the temperatures. And so when you're operating in the sweet spot for a heat pump, as Joe was talking about, the 30s, 40s, 50s, that heat pump's going to be at its most efficient and therefore economical. And it's only the rare frigid weather where maybe the furnace can be a little bit more cost effective. But that doesn't happen very often, and it's happening less every year.
the other number you may consider in your furnace is to look at the number of therms you burn. It's on your bill. You can look at the number of therms. When I did it, I found I used 1,026 therms of natural gas, which is basically methane, to heat my home. How much greenhouse gas do you think that made? Nobody knows unless you do the calculation. 5.6 metric tons of greenhouse gas that goes into the atmosphere for 100 years.
Yes, and thanks, David, for mentioning that, because one of the some of the slides I skipped over in the interest of time that you'll have in your backups when Stephanie sends them out is the all those calculations of therms, and you can actually do your own math for how much is it going to cost to operate a heat pump versus a furnace, and you can also do the math that David talked about of how much CO2 are you talking about with those therms, and those slides in the back there will show you how to do that math yourself. And you can put in your own utility rates, how much you're paying for electricity, how much you're paying for natural gas, and figure out the economics. But generally speaking, in this area, like I said, it's about the same. So you're not going to save money, but it's going to be about the same cost to heat your home and a little bit less to air condition it.
Well, thank you guys so much for your very thorough responses, and thank you to everyone for sharing your questions and being so engaged. And I really appreciate everyone staying so far over time. I'm
Yeah,
sorry
yeah.
this ended up being so long, but your presentation was very comprehensive, and I appreciate that. And I'm glad we'll get the chance to share it with people so they can take their time going through all those slides. And I've taken a lot of notes here so I'll try to highlight some of the key takeaways in the follow-up email as well. But I really appreciate both of you, Bob and Joel, for putting this together and sharing all these insights. And I know I personally learned a lot. So we'll be sharing this with other folks who couldn't make it to the meeting today. That way they can still watch the presentation as well as going through the slides.
Yeah, thanks, Stephanie, for hosting this. And I'll repeat what I mentioned at the beginning, that if people do have more detailed questions for their own particular home, they can always get in touch with us at Go Electric DMV, and we can help them one-on-one.
Awesome. Thank you for that, Bob. And just a disclaimer for our CAB members here as well. If there are any topics that you'd like to see us cover in future meetings, please reach out to me by email or respond to any of the Community Advocacy Board meeting emails with suggestions. We chose this topic based on feedback from you all, so we want to make sure that we're presenting on topics that you're interested in. Our next quarterly meeting will actually feature Bob again talking about electric vehicles. So you'll be getting emails about that soon as well.
And electric vehicles going to the national parks.
Yes, even more exciting. Yeah,
Yeah.
Bob has a wonderful story to tell. So join us next time for that.
Thanks, Stephanie.
Okay, thank you, everyone. Have a good one.
Bye.
Bye.
Thanks.
Thank you, Joel.
Thank you.
Thanks, Joel.
Thanks, Stephanie.
David, thank you, David.
Yeah, thank you too, David.